We are doing these notes as a video because it is a review of old material, and that way tomorrow when Mr. Wilson is in class with you guys, you can have an in-class practice day. You will be required to show him your completed notes at the beginning of class to make sure that everybody actually watched the video. So systems of linear equations can be solved algebraically a lot of ways, but the two ways you guys have previously learned are substitution and elimination. Substitution, the first step is to rearrange one of the equations to isolate a variable. It doesn't actually matter which equation you rearrange or which variable you isolate, but a lot of them are set up so that one of them would be easier to isolate. And for example, this problem right here, the first equation is easiest to isolate y. So that's what I would do, is I would just subtract the 2x to move it over, and y is isolated. The second step is to take that and substitute it into the other equation. And so if I did that, I'm going to take this equation and I'm going to substitute it right in there into the other equation. If you make the mistake of accidentally substituting it back into the equation it came from, you're going to get infinite solutions, and so you don't want to do that. So I would take my second equation, which is 3x plus 2, and then instead of y, I would put negative 2x plus 4, and then it's equal to 1. And then the third step is, of course, solve. So in this case, I'm solving for x. It could have been, depending on which direction we substituted, we could be solving for y first, but we're going to solve for whichever variable is remaining in the equation. So I'm going to state that. I'm going to say solve for the remaining variable. And so in this case, on this example, I would distribute the 2 through the parentheses. And then I would combine my like terms, and I would have negative x plus 8 is equal to 1. Subtract the 8, get negative x is equal to negative 7, and so x is equal to 7. And then the fourth step would be to plug that in. So plug whichever solution you just got into one of the equations. And it doesn't matter which one. I'm going to go ahead and I'm going to actually not even use the first equation. I could use the first equation, but I have a nice, beautiful rearranged version of that first equation where y is isolated. So I'm actually going to do that. I'm going to plug my solution for x into that, and then I finish evaluating it and I get negative 10. And then one of the easiest places to get lazy and miss points is you need to write the solution as an ordered pair, because remember the invisible word anytime you list solutions is or. And so if you simply box x equals 7, y equals negative 10, you're telling me that any point that has an x value of 7 or any point that has a y value of negative 10 is a solution, which is not true. It's got to be the point that has x is 7 and y is negative 10. So it seems like it shouldn't be a big deal, but it absolutely is. You've got to write your solution, or you've got to put the word and in between those two solutions. Okay, so now you guys are going to try number 1, 2, and 3. So you're going to pause the video and you're going to give those a try. Okay, when you're done with those, unpause the video and check your answers. Okay, you should have paused the video and tried number 1, 2, and 3. Number 1 was already set up so that when you take this equation and this equation, we already have y isolated, and so technically when you're substituting, you're just setting those two things equal to each other. And so when you work your way down, what you should have ended up with is a solution of 3, 1. The second system had a second equation that was already rearranged so that one of the variables was isolated, so we would plug it into the second equation, and so we would have had a 2, and then x would have been replaced with 1 minus 4y, and then we still had the plus 7y, and it was equal to 3. So this time around you're going to solve for y first, and as you work your way down, what you should have figured out is that your solution is the 0.5, negative 1. And you always want to check your answers and make sure that that point works in both equations. And then the third and final system, the first equation, you could have rearranged it to get y by itself. And so then you would have plugged it into the second equation. So at that point you would have had a 5x plus 2. Y would have gotten replaced with negative 5 halves x plus 4. And it's still all equal to 8. This time around, as you work your way down, when you distribute the 2 through here, this is what you end up with. You end up with minus 5x plus 8. And when you combine your like terms, the x's cancel, and you end up with this. 8 equals 8. And so remember the question you're answering? The question is, when do these two lines intersect? Well, so then you ask yourself the same type of question when you get to right here. You ask yourself, when is 8 equal to 8? The answer is always. And that answer is also the answer to the original problem. When did those two lines intersect? Always. And so what that means is that we have infinite solutions. That means the lines do what we call coinciding. And that was on yesterday's in-class notes, or Tuesday's in-class. So they are coincidental or coinciding lines. So we have infinite solutions. They overlap each other. The other method that we're going to review is elimination. And this one, I could literally take one problem and I could work it 4 different ways. So I'm going to show you, I guess, 2 different ways, and then you guys can decide from here on out which way you like doing it. And the reason there's 4 ways is because the first thing you want to do is you want to choose which variable you want to eliminate. A lot of times it's random. Sometimes the system is set up so that one will cancel more easily than the other, but it is a choice. So that creates 2 different situations. You could choose x to eliminate, you could choose y to eliminate. But then the reason that it ends up being 4 decisions is because you get to choose whether to combine your 2 equations through addition or subtraction. And that is why the combination of the 2 equations is why the elimination method is sometimes also called the combination, linear combination. They are synonymous and interchangeable. So you get to choose. Do you want to cancel x's? Do you want to cancel y's? Do you want to do it through addition, or do you want to do it through subtraction? You need to make those decisions before you figure out what is it I need to multiply my equations by. But you're going to need to multiply one or both equations by a constant to make the coefficients either opposites or identical. So make the coefficients that you're trying to cancel opposite or the same. So let's say that I decide I want to cancel my y's first. And I like doing it through addition because then you don't have to worry about distributing a minus sign through everything and getting careless with the subtraction process. So I'm going to cancel my y's, and I'm going to cancel through addition. So what that tells me is that if I want to cancel my y's by adding my 2 equations together, I need the y coefficients to be opposite of each other. So what I figure out is what is a common multiple for a 3 and a 5. And so I'm going to multiply this one by 5. I'm going to multiply this one by -3. And so what it does to my first equation is it applies the scale factor to the entire equation. That's why it stays the same equivalent equation. And so it becomes 30x plus 15y equals 30. And then my second equation, when I distribute the constant through, becomes -24x minus 15y equals -36. So when I add my two equations and I add down, my x's are lined up, my y's are lined up, and my constants are lined up, my x terms will combine to give me 6x. 15y plus -15y cancels out, my y's are gone. And 30 plus -36 is -6. And then I can solve for x and get -1. Okay, so what I just did was I combined the equations to eliminate one of the variables. I solved for the remaining variable, whichever one was left over. And from there, it's just like substitution. Anytime you get one of the variables' solutions, you simply plug in and solve for the other one. So plug in and solve for the other variable. And it still doesn't matter which equation you plug into. So I'm just going to go ahead and plug into the first equation, the 6x plus 3y equals 6. So I plug in my solution for x, which was -1, plus 3y equals 6. So I have -6 plus 3y equals 6. So I have 3y equals 12. So y equals 4. And then just like before, I need to write that solution as an ordered pair. -1, 4. There's my solution. Okay, now I could have done it a variety of other ways. I could have taken the 6x plus 3y equals 6 and 8x plus 5y equals 12. And I could have decided I wanted to cancel the x's instead. And I could have decided I wanted to do subtraction instead. So if you want to do subtraction, that's fine. But that means that your coefficients need to become the same, not opposite. So let's say decide I wanted to cancel my x's by subtracting the two equations. So what I would do is I would make the two x coefficients become identical to each other. And the common multiple for 6 and 8, you don't really want to do 48, but if you decided to, that's fine. But both numbers go into 24 as well. So I would multiply this by 4 and multiply that by 3. And so my first equation would become 24x plus 12y equals 24. My second equation would become 24x plus 15y equals 36. And so then, when I subtract the two equations, I need to remember that everything on that bottom row down here is being subtracted. So 24x minus 24x would cancel. 12y minus 15y is -3y. And 24 minus 36 is -12. And then I would solve, and I would get y is equal to 4, which is still the same y value that I had before. But then I've solved for y first, so then I would plug that back into either one of the original equations. And so I would have 6x plus 12 is equal to 6. So 6x is equal to -6, and x is equal to -1. And so I get the same solution. But when you use subtraction, you need to make really sure that that subtraction distributes to everything in that second equation, or it will completely screw it up. That's why I typically use addition every time. So now you guys try 4, 5, and 6. Pause it. When you're done with 4, 5, and 6, turn it on and check your answers. Okay, so the answers that you should have come up with for number 4, 5, and 6 were 2, 1, 4, -1, and -1, -2. If you didn't come up with those answers and you can't figure out why, then you can always remind message me or email me, and I can post a video explanation of how to do that particular problem. Otherwise, tomorrow you're going to walk into class on Wednesday. You're going to show your notes to Mr. Wilson, because I'm at central office for a GT teacher training. He will check off that you watched the video and did the notes, and then you will do some in-class practice with your substitution and elimination. And then the answers will be available for you to check. Okay, see you guys on Thursday.